we're going to learn a different way to write an expression that involves a variable being less than or greater than or between two numbers, called interval notation. The reason I'm showing you this is almost exclusively the way that these things are described in upper level math textbooks. Once you get beyond pre-calc, you'll probably not see y greater than or equal to 3 as often, if not hardly at all. And so you need to understand interval notation. You're going to see it on standardized tests. You're going to see it on college placements exams. You're going to see it in college textbooks. So we're going to exclusively use interval notation, kind of gradually work our way into the point of that's the way we're always going to describe an interval. So let's look at how interval notation works. In an interval notation, we start with the smallest number in the interval on the left and the largest number on the right. So we have y is greater than or equal to 3, which means the smallest number in our interval is 3. Now, what would the largest number be? Well, there is no largest number. We say y is greater than 3. So if there is no largest number, then we say the largest number in our interval is infinity. Now we need to describe the endpoints of the graph. We say greater than or equal to. So I call that a firm endpoint. We know exactly where that interval ends, exactly on 3. So since it is a firm endpoint, I make a nice firm corner here and put a square bracket here. Now, going to infinity, infinity is not really a firm endpoint. It just keeps going on and on and on, and it doesn't really have a definite endpoint. So we put an open bracket there, or a curved bracket to indicate an open, kind of an open-ended endpoint there. If we were to make a picture of this on a number line, it would look like this: a closed circle and an arrow going that way. Now we have y is greater than 3. That means y could be any number bigger than 3. It could be 3.2. It could be 3.1. It could be 3.01. It could be 3.0000001. It could be as close to 3 as we want, but there is no definite endpoint. We know it's up to 3, but not including 3. So we put an indefinite endpoint on that. So when we don't have the equal sign, so when there's no equal sign, we use the soft bracket, and we would still use infinity here, and this would be equivalent to an open endpoint going to infinity to the right. So what would we do if we have x or something in between 2? And I just noticed I use y, I could use x, I could do anything, I could use any of my variables here. So what if I'm doing -1 is less than y is less than or equal to 3? Well, -1 is not equal to. This is a soft endpoint. -1. And then 3 is a firm endpoint, exactly equal. So this would be equivalent to having an open endpoint here on -1 and a closed endpoint at 3. So that's how we would write that in interval notation. Now, how do we write all real numbers in interval notation? Well, all real numbers means that we go infinitely in both directions. So we say negative infinity to positive infinity. That is the same as all real numbers. Now, if you have trouble making infinity signs, okay, it's kind of like go up, kind of make a little curve like that, and then loop this around and go back the other direction. Kind of like a figure 8, only sideways. That's the infinity sign. So, to summarize, square brackets is a definite endpoint exactly equal to that number. Parentheses, no definite point, meaning not equal. So greater than or less than. So this would be greater than or equal to, less than or equal to. This would just be greater than or less than. Infinity does not have a definite endpoint, so we use the curved brackets for that. Always remember, too, to put the smaller number on the left. So you wouldn't want to put, for example, infinity to -3. Okay? That would be a little confusing, because when I see that, are you talking about going to the left of 3? Negative infinity to -3, or trying to say to going to the right of 3? So you always want to go left to right. So you would want to write that as -3 infinity. Okay, so you put the infinity on the right. Or -1 to 5. You would put -1 on the left, 5 on the right. Another thing that I want to point out is when you have a number in between two numbers, the inequality sign should be facing the same direction. So here I'm saying that y is greater than -1 and y is less than 3. So I should have y being greater than -1 and y being less than 3. I see a lot of students who will do something like this, and they'll write -1 is less than y, and they'll put it kind of like that. That is wrong. We don't want to, because that's saying that y is greater than -1 and y is greater than 3, but we want y to be in between them, so y should be less than 3. So we need to have, when it's in between, make sure that inequality signs are going the same direction. If y is not in between the two numbers, if you're really trying to say y is less than -1 or y is greater than or equal to 3, then you should have two separate inequalities. You should say something like y is greater than -1 or y is greater than or equal to 3. Okay, so we don't try to combine those together into one statement. All right. So I'm not going to put that down because it's kind of confusing if somebody just looks at the written notes. Okay, so let's look at the domain and range of this function. So we're going to do it first using inequalities and second using interval notation. So if we look at the x values first, what's the smallest x value that we see corresponding to something on the graph? Okay, so we see -5, and then the largest one is 4. And we see that every value of x in between corresponds to some value on the graph. So there aren't any gaps in this graph. It's a continuous graph from -5 to +4. Notice, though, that this is an open circle. Open circle. So that means that x doesn't actually equal anything at -5. It's just it gets really close to -5. So the domain is -5 is less than x, but it's less than or equal to 4. So if I were to actually label this point, this is the point 4, 1, or sorry, 4, -1. You label it 4, -1, and then this is the point -5, -1. So we see that we go from -5 to 4, but just not including the -5. Now, if we wanted to write this in interval notation, open circle at -5. I'm sorry, so open circle at -5, so soft bracket or curved bracket, closed circle at 4, 4 is included, firm bracket here. Okay, the square bracket. Now let's look at the y value. What is the very lowest y value that has a point on the graph? Well, -1. There's several places where y is -1 on the graph. What's the highest place where there's a point on the graph? 3. So the lowest point is something -1. So we have 1, -1, for example. Highest point here is -1, 3. So we can see that y goes all the way from -1, and -1 is included because there is a point there, all the way up to +3. So we can say -1 is less than or equal to y is less than or equal to +3. So we would say -1, +3 in interval notation. Now I want to go back briefly to the previous page of the notes where we did where we looked at some domain and range using graphs, and actually it's a couple pages back. All right, and let's go back and put a couple of these into interval notation. All right, so we see x is greater than or equal to 0. So what's the smallest value? 0. So we put that on the left. Does it equal? Yes. So we put a square bracket, 0. Then anything bigger than that, so it goes to +infinity. All real numbers, -infinity to +infinity. Okay. Same thing, any place there's an all real numbers, it would be -infinity to +infinity. I'm not going to write it for all of them because it's the same thing for all of those. Y is greater than 0. Okay, what's the smallest value? That goes on the left is 0 all the way to infinity. But 0 is not included. It's just greater than 0, so we put a curved bracket here and always a curved bracket in infinity. Y equals 2. and x equals 2. We can't write an interval for that, so basically those would just stay the same. Y is equal to 2, x is equal to 2. There's nothing else we could do with that with an interval.